Let's talk about LCMs, large concept models, and whether they're actually as big of a breakthrough as people are making out. Let's get into it. So the first thing is ai.meta.com, large concept models, language modeling in a sentence representation space. Now, I understand the vague concepts behind this. Basically, LLMs predict the next token, LCMs predict the next topic or concept or, whole thing instead of just the next token, which basically means that they should be more that kind of context aware, basically. I think that's the whole point behind this. But let's have a look. So LLMs have revolutionized the field of artificial intelligence and have emerged as the de facto tool for many tasks. The current established technology of LLMs is to process input and generate output at the token level. This is in sharp contrast to humans, who operate at multiple levels of abstraction, which is true, well beyond single words, to analyze information and to generate creative content, which makes sense. Humans take everything into account when you're having a conversation, right? Whereas LLMs, as we all know, one of their main weaknesses is they just kind of always have an answer, and they never say, you're not right, or I don't know if that's correct, or they always just say, yes, you are correct. Let's completely ruin your code because I'm going to just assume you're correct without actually checking. So this is really, really interesting. In this paper, we present an attempt at an architecture which operates on an explicit, higher-level semantic representation, which we name a concept. Concepts are language and modality agnostic and represent a higher-level idea or action of flow. Hence, we build a large concept model. In this study, as proof of feasibility, we assume that a concept corresponds to a sentence and use an existing sentence embedding space, Sonar, which supports up to 200 languages in both text and speech modalities. The large concept model is trained to perform auto-regressive sentence prediction in an embedding space. We explore a lot of this. I don't fully understand. I'm not going to lie. I'm not trying to say I'm something that I'm not. I'm not an AI researcher at all, but I think I can understand the basics here. We explore multiple approaches, namely MSE regression, variance of diffusion-based generation, and models operating in a quantized Sonar space. I have no idea what that even means. These explorations are performed using 1.6 billion parameter models, so quite small models, and training data in the order of 1.3 trillion tokens. We then scale one architecture to a model size of 7 billion parameters and training data of 7.7 trillion tokens. We perform an experimental evaluation on several generative tasks, namely summarization and a new task of summary expansion. Finally, we show that our model exhibits impressive zero-shot generalization performance to many languages, outperforming existing LLMs of the same size. The training code of our models is freely available. So as usual, they've open sourced everything, which is amazing. This is very, very interesting. But instead, we're just going to kind of go through a few different sources that I've found, which hopefully will make things a little bit easier to understand. So on the left here, you can see Tim wasn't very athletic. He thought that would change if he joined a sport. He tried out for several teams. He didn't make the cut for any of them. He decided to train on his own instead. So this is, on the left, I guess, the concept model. And on the right, it's just an LLM. Or it's the other way around, I'm not actually sure. Here, concept decoder fixed, large concept model, concept encoder fixed, words, concepts, words. I'm not really understanding what this means. However, this blog post should help us out a little bit. So I'll leave this blog post in the description of this video. We understood the issues with current tokenization methods and available methods to overcome them. We saw how we played with the pre-processing and encoding block to make a robust and efficient architecture use at scale. The decoder and BLT also followed the same paradigm. The only thing we kept generic was the central processing block, which was a simple transformer architecture with slight changes, but the core mechanism remained the same. This article follows the work on and around the processing block in a recent paper from Meta called As Large Concept Models. We'll discuss the methodology, outcome, and underlying algorithm thoughts behind it. But before that, let's make a quick diversion for setting up the context. Okay, so instead of going through loads of different complicated papers and things like that to kind of understand this concept, let's just ask Perplexity. So I said, Perplexity, can you explain Meta's new large concept models to me in simple terms? Meta's new large concept models, LCMs, represent a significant shift in how artificial intelligence processes and understands language. Here's a simple explanation. From tokens to concepts, traditional AI models like ChatGPT or Gemini work with individual words or parts of words called tokens. In contrast, LCMs work with entire sentences, treating them as complete concepts. So this is very, very interesting, because one main criticism I've always had with AI is that it never really seems to feel connected. Like each word from the next word doesn't really seem to feel connected, because it never really seems to take the concept as a whole into account. It's always seemed to just, feel the need to generate the next token. And this is why it makes a lot of sense. So how it works: sentence level processing. Instead of breaking text into small pieces, LCMs take whole sentences and turn them into vectors, mathematical representations. So I am familiar with this. I'm familiar with the concept of taking a large amount of words and vectorizing them, which basically means putting them, representing them as vectors instead of as words. But the vectors are just a mathematical representation of each letter, if that makes sense. So instead of just taking each letter and vectorizing them, it's taking each sentence at a time and vectorizing them. Sonar space. These sentence vectors exist in a special space called sonar, which can handle up to 200 languages in both text and speech. Concept-based thinking. By working with entire sentences, LCMs aim to understand and generate language more like humans do, thinking in complete ideas rather than individual words. Potential benefits: multilingual capability. I mean, GPT-4 already has multilingual capability, but LCMs could potentially handle multiple languages without extensive training for each one. Improved coherence. This would be the main advantage of this I could see, because it often feels like our current AIs, no matter how good your prompting is, no matter how good your system is, like Harbor, for example, it always feels a bit disjointed. It always feels like word vomit on a page instead of actually thought about wording and concept and the entire article as a concept. Actually, this is super interesting, because one of the hardest things I've had with Harbor is getting it to write an article as you would expect an article to be written. Now, a model like like Anthropic Claude 3.5 Sonnet works really, really well with this, and it does it really well, and it understands your prompting, and it kind of gives itself the persona of a content writer. But if you're trying to do the same thing with something like GPT-4o Mini, I'll tell you right now, it's fucking hard, okay? And it took me a long time to get GPT-4o Mini into Harbor. So I think this is more true, what they're talking about. This is more of a fix for stupider models. Something like Anthropic or 3.5 Sonnet can do this with good enough prompting already. Efficiency. Working with sentences instead of individual tokens could make processing long text more efficient. Current status. While promising, LCMs are still in the research phase. Meta has released the source code, but not the pre-trained weights, suggesting the technology is not yet ready for direct comparison with current top AI models. In essence, Meta's large concept models aim to make AI think more like humans by working with complete ideas rather than individual words, potentially leading to some more sophisticated and natural language understanding and generation. So I think this could be huge for people who are not that good at prompting and don't have, the ability to chain together 12 different prompts with different data sources and different whatever. Harbor, for example, though, Harbor with Claude 3.5 Sonnet is really, really good. But what people are always talking about is like base level reasoning. So like if anyone opens up their conversation with Claude or whatever, the ability to get what they want from that conversation without hugely ridiculous amounts of prompting and thinking and, prompts like perfection and everything, like slowly making that prompt perfect. What it should be is you should be able to open up your conversation with an AI, write a very simple prompt, and it should be able to give you exactly what you're looking for, which is where something like this is interesting. It's not that interesting, though, if you're kind of, I hate the word prompt engineer, but like kind of prompt engineering, or you're good at getting what you want out of sophisticated AIs. This isn't going to be such a huge step forward. If you're a bit of a noob and you just want to be able to do a simple prompt and get exactly what you want from it, That's where something like this is going to make a big difference. What I think this is mainly going to do, though, is it's just going to be I reckon this will be the new norm. I think tokenization is going to be a thing of the past pretty soon, and instead AIs are going to have much more understanding and context of what they're actually talking about instead of just word vomiting on a page. Like I said before, 3.5 Sonnet with correct prompting already does that, but you shouldn't need to spend 60 hours perfecting prompts just to get what you want out of AI. We'll leave the video there, guys. Thank you so much for watching. Happy New Year and all that good stuff. If you're watching all the way to the end of this video, you're an absolute legend, and I'll see you very, very soon with some more content. Peace out. Watch this video if you're interested in the 2024 December algorithm update and who it hit, why it hit certain people, and what you could maybe do to fix it.